Hello and welcome to the Geostatistics course for beginners with QGIS and R. This is the 6th lesson of this course, and for this lesson we are going to be talking about univariate analysis. Today we are going to start creating a table. It's going to be a specific script that is going to create a table with the basic statistics of the Meuse River dataset. To do that one, then we are going to create a new script, and I'm going to paste the work I did already. Paste over here, and here there are new things. We know about the group, we know about the layer. It's going to be a vector layer where we are going to extract the information. This is the parameter that we are going to analyze. In this case, it's going to be sync. And in this case, as you can see, we are adding a new line that the output is going to be a table. That is also very interesting, because if we have a table that we can manipulate with Apache, with OpenOffice, then we can customize also the table. Then in this script, what we are going to do is create an object. This object is going to be the summary statistics, and it's going to be a data frame. Then what we are going to put inside this data frame is all this data. This data is related with the parameters that we want to have in our table. It's going to be the summation, the length, the unique values, the minimum, the maximum, the range, the mean, the median, and the quantiles. The first and the third quantile, and also the standard deviation. Then what we are saying here is that we want these names for the columns, I mean for the rows, and the name of the column is going to be the parameter, this parameter, and it's this parameter. And then what we are saying that the file is going to be named as a stacked, okay? This object is going to be this file. Then we are going to save this one. Here, that one is going to be number 11, and it's going to be saved as a basic stacks. And save. And I'm going to close this one, and I'm going to run the script over here. That's 11. Double click, and the layer is already loaded because it's the only one that we have as a vectorial layer. Then the parameter is going to be the sync, and we are going to save this one in this folder, this one, and we are going to put the name stats. Save and run. Then we can go to the folder. Is this folder, and is stats. That's the name of the file, is this one over here. Then double click to open. Remember that if you want to download this software, this is a free software and open source. You can go to my website, go to resources, then here go to this link over here, and you can download. Is this one over here. Then okay, and I'm going to open as a copy. Now I am going to make this screen bigger, and as we said previously, we have here the sync. That's the parameter we are doing the analysis. This one is the summation of all concentrations for the total of the samples. The total of samples is 155, the unique values are 140, the minimum value, the minimum concentration, and this is in ppm, it's going to be 113. The maximum also in ppm is 1839. The range is the difference between these two, and is 1726. That's a ppm. The mean value is this one here. This one has too much decimals. This one. This one is good. This one is the median, the first quantile, the third quantile, and the standard deviation. We can take. Then this table can be customized as you want. You can add colors. You can do anything, right? With this table, also here you can add some colors, and then copy and paste on your report. You have a lot of different options, right? But that one is pretty intuitive. Now I would like to show you how you can calculate the median value from your data set. Then we are going to open the Meuse River data set. It's this one. Open. Okay. And let's go to order the values, the concentration for the sink in descending order. Then I'm going to select this column, go to data, sort, extend selection, and descending. Okay. And now we have here the highest value, and at the bottom we have the lowest value, right? That's the values we calculated with the script. The maximum here and the minimum here. Now, in order to calculate the median, what we are going to do is select the sample that is located just at the middle, okay? Then we have 155 samples. Then if we divided this number by 2, 155 divided by 2, we are going to have 77.5. Then we want from this range, we are going to have the sample 77, the sample 78, and the sample 79. Okay, then what we want to take is this sample. This sample is just at the middle, right? Because if we plus 77.5 plus 77.5, it's going to be 155, right? Then the middle is just the sample 78. Then what we are going to do is go to the data set and look for that sample. Be careful because here it started at number 2 and we want here number 1, right? Then the value we are looking for is 77, but we have to add one more because it started at 2. Then the sample that we are looking for is the next one, is this one. This one is going to be the sample 78. This one is 326 and is the sample that is located just at the middle, okay? Then if we check the table, the script we're calculating the median, we are going to see that is the same value. Here we have 326 and here we have for the median value 326. In this case, the total number of samples, it was an odd number, but if you have an even number, what you are going to do is just, for example, let's go to add the 80 here. If you have an even number over here, you are going to take the average of these two samples, the two samples that are located just at the middle of your range of samples, and then make the average of these two values, and then you are going to get the median value. Now let's go to see how to calculate the mean value. Hey, do you know the Geo RGB community has a Facebook page? I'm going to leave the link at the video description, then you can click and follow us in this page. I'm going to be posting some content here that you are not going to see on the video tutorials in YouTube. Also, remember, if you want to have access to the scripts that we are using at the course, go to the Geo RGB community website, go to courses, then click on this course, start the course, and then go to the lesson. For example, for lesson 4, click on the lesson, and here you are going to have the attachments related to the scripts that we was using in this lesson. Remember that I'm going to post the scripts exclusively at the Geo RGB website. Okay, let's go to continue. The mean value is going to be the average. Then go here, go to the bottom of this table, over here, then this one is going to be equal to the summation of all these ones divided by the total number of samples. Then what I'm going to put here inside this one is going to be all these values over here. From here to the bottom. To here. And let's go to run this one. And this one is 470. And that's the value that we get over here. But here there is one decimal. We can add one decimal here to have the same value. Okay, as you can see. Now, in order to introduce the next script, I would like to be focused in these three values. Remember that we can calculate these values from the cumulative distribution function, as we saw on the lesson 4, that the first quantile is related with the probability of 0.25. The median is related with the probability of 0.5. And the third quantile is related with the probability of 0.75. And one really important thing related with all these values is that they are an estimation values, okay? Then what we have here is all these samples. And for all these samples, we are going to estimate what is the median value and also the mean value, but it doesn't mean that is the mean value or the median value in all this area, because as we are adding new samples or we are taking samples from this area, that values are going to change. Then we don't know what is the real values for this area. What we are doing is just an estimation with the samples that we have, and that is also really important, because sometimes maybe our samples are not totally representative of our area, right? And then we have a mean value and a median value that is no good because the data of our samples are not representative. Then we have to be very careful that when we are saying that our median or our mean is something, that is just an estimation, and that's really important, okay? Now let's go to create a new script to make the graph related with the box plot. That graph is really good to see the interquartile range, and also to see the first quantile, the third quantile, the median, and also identify the outliers. Then what I'm going to do is go here, create a new script, and I'm going to paste over here. And let's see. There is nothing special. We know about all these things. And for this script, we are going to use this one. That is for the box plot, and that's the labels and the themes, and there is nothing special. We know about all these things already. Then I'm going to save this one as a 12 box plot. Save. I'm going to close this one, and I'm going to run the script. This one here is number 12. Then this one is already loaded. It's going to be for the zinc, and I'm going to add the labels here. Here is going to be the zinc concentration in ppms. This one doesn't have any value here. The title is going to be box plot, and subtitle is going to be raw data. Then let's go to run the script, and let's see how it looks like. Now let's go to see how we can make the interpretation of this graph. I created a slide to make the explanation, and here we have all the elements that we can find in the box plot. Then first we are going to talk about the first quartile, the second quartile, that is the median, and the third quartile. That is the values that we saw over here in this graph. First quartile, second quartile, and third quartile. And that's the same, and as it is the probability associated with each of these quartiles. And here at the box plot, we have the same information. This one is the first quartile. This one is the second quartile, that is the median, and this one is the third quartile. That is the probability associated with 0.75. Here the probability associated is 0.5, and here the probability associated is 0.25. Then the distance from the first quartile to the third quartile is going to be the interquartile range and is known as IQR. Also, we have the range that goes from the first value to the last value and is over here. And in this case, in the case we are talking now, it's the ppm concentrations from the minimum value to the maximum value. And now we can have the distance, the maximum distance from here, from the third quartile to here. The maximum distance is going to be 1.5. The distance of the interquartile range is 1.5 times this distance from here to here. That is the maximum distance that we can have. Then if we have values that goes farther to that range, is going to be considered as outliers. It also happens here for the minimum. The maximum range that we can have from here to here is going to be 1.5, the interquartile range, okay? Then if we have values that goes farther to that range, is going to be considered as outliers. Remember that to identify the outliers in your set of data, it's really important because these values are pretty different of the rest of the values in your range. Then to identify that values is going to be really good because if we see that we have outliers, we can treat that one in a different way, right? And see what happens if we remove that values from our data, then make the analysis. And because the outliers can modify a lot the mean value, okay? And we are using the mean value to do a lot of different kind of statistics. And sometimes if the mean value is not representative of all your data, it doesn't worth it, right? The mean value is not good. Then you have to see what happened with these values. It doesn't happen with the median. The median is not really affected for the outliers, but the mean value it's really affected. And it is really important to identify what happened with your set of data. Because as I said, if the mean value is not representative of your data, you cannot use the mean to do some type of statistics, okay? Now let's see what the graph is saying about our data. As you can see, we have here the first quantile. I'm going to make this screen bigger. Then the first quantile goes from the beginning of our range to this line over here. And as we can see, the 25% of our first samples are located just in this small range, right? From here to here. And we know all these values because we calculated on this table. We know the beginning of our range is the minimum value, is 113 ppm. And for the first quantile, we have 198 ppm. Then the 25% of our samples, the first ones are located between this range, okay? And that's what we can see in this graph over here. Sorry, this one over here, from here to here. Then in the next 25, here we have the median. We have all these samples, right? We have the 50% of the samples is over here, and that goes from 113 to the mean value is 326 ppm, right? That is the value that we are going to find here, 326 ppm. And that is pretty interesting, right? Because as we can see in this graph, the skewness of this graph is really high, right? Because from here to here, we have 50% of the samples, okay? That's the reason because this box is not located at the center of the graph. It's very close to this side because we have most of the samples in this range. Then at the third quantile, that is the distance from here to here, the samples are quite spread, as you can see, because this distance from here to here is higher than the distance from here to here, right? It indicates that here even we have 25% of the samples, but this distance is almost 3 times this distance, right? It indicates that the samples in this range from here to here is spread 3 times this distance from here to here, right? In terms of the sample distribution. And for the last 25% of our samples, what we can see is the distribution, it's really spread, because the distance from here to here is longer than the distance from here to here. But from here to here, it represents 75% of the samples, and this one represents just the 25 of the samples. Then what we can see also that this distance from here to here is covering 1.5 of the interquartile range. That is this distance from the first quantile to the third quantile. And then for the rest of the samples that go farther is going to be outliers. In this case, we have 6 outliers. Then what you have to do is check what is these values on your table. For example, go here, let's go to the top, let's go to pick up the 6 first values. This one is the highest ones and they are related with the outliers. Then go to the map and see if those values are together, are separated, what happened with these values, right? But that one, as we are taking in consideration the coordinates of the data, is going to be part of bivariant analysis or also multivariant analysis. And it's not covering in this section because this section is just related with the univariant analysis. Then that's it for this graph. Just a summarize, remember that one is the first quantile, this one is the second quartile, that is the median, this one is the third quartile, here we have the outliers, and this distance from here to here is the interquartile range. Now let's go to see how we can combine the box plot with a histogram. That one is going to be a very powerful diagram where we are going to see a lot of information about our data. Then I'm going to paste here the script, and we know all these things already. Here I added a new library. Then this script is going to take longer to run because it has to install this package. Then also I created for this graph 2 different objects. This one is going to be A and it's related with the histogram. Then the second object is going to be this one, that is going to be B, and this one is for the box plot. And this one is to make both graphs together in just one. Okay, this script, it took me a little bit of time because there are a lot of editions, and hopefully you see the hard work on this graph because it is a really good graph, and I really appreciate if you leave a like on the video because it took me a bit of time. It was a hard work with this graph, but as you are going to see, it is an amazing one. Let's see what we can get in this script. This library is to put both graphs together. Then here for the histogram, we are going to use the count for the number of samples at the y-axis. Also, I added the breaks, to add our interval from the minimum to the maximum, and also decide what number of bins we want. Then we have the labels, and also I added these 2 lines that is related to the mean and also to the median. We are going to have these 2 values in the histogram represented with a line. Also, I added these 2 lines that is going to allow us to put a label on these lines indicating what is the mean and what is the median. And also these 3 lines are related with the themes for the title, subtitle, and also for the axis. The box plot is the same as you see before, but in this case I added the mean value, because it is important to see the median and the mean value. If they are close or they are very separated, that is an important thing that you have to know from your data. And also the last line, it's for compile both graphs, okay, and the relation between them, right? This one, the box plot, is going to be 10 times smaller than the histogram. That is for aesthetics of the graph. Okay, now I'm going to save this one as a 13, and it's going to be histogram plus box plot. And let's go to save. Let's go to close this one, and let's go to run the script. This one is 13, and okay, sync. For the X value is going to be sync concentration in ppm. For the Y is going to be frequency. Title of the graph is going to be histogram plus box plot. Subtitle is going to be raw data. The range is going to be this 113. That is the minimum. The maximum is going to be 1839. The range is going to be calculating. Is going to be for a 12 bins. Then I'm going to put the calculator, and I'm going to make the differences from 1039 less 113 divided by 12, because I want 12 bins, is this value. Then I'm going to select all, and I'm going to copy and paste here. Okay, I'm going to fill all this data, but I'm going to pass the video faster. And also I'm going to save the graph. Save, and I'm going to run. As I said, it's going to take longer because he has to install a package. I'm going to pass the video faster. Okay, let's go to see the graph. And let's go to make this one bigger. A little bit less. But I'm going to move this label to the other side of the line to be more clear. Then it's going to be moved to the value 500. Yes, then you can see how I'm doing this one. Then here, edit the script, and I'm going to move the mean value is this one to 500. Then I'm going to put here 500, save, and I'm going to run the script again. This one run. And that's it. Going to open, and I believe now it's a little bit better. As you can see, now it's better. Well, this diagram is really good. Here we have the distribution with all the samples. Here we have the frequency. Here we have around 64 samples. Here we have around 21 samples, and etc. Also we have the median value, that is the same as we can see here at the box plot. Also I added the mean value for the histogram and also for the box plot, and that's really good. Okay, we have here the range from here to here. That is the same range that we have here. Also we have the outliers over here, and we have the samples that we have in this range, as you can see. The only thing that is not good with this graph is that the labels for median and mean has to be placed manually. I'm going to show you now with a different set of data how you can do that one, but that's the only inconvenience that this graph has. But for the rest, it's really good. Now I would like to show you these two graphs, but with a different data set. Then we are going to see how to place the labels in the graph. And also we are going to see something very different, right? Because this graph, the skewness is really big, it's very asymmetric, but for the groundwater elevation, we are going to see that the distribution is pretty normally distributed. And then we are going to see how is the behavior of the box plot with the relation of the histogram, and also the relation between the median and the mean. Then what I'm going to do is close this one. I'm going to close this one, and I'm going to open QGIS again, but now with the other data set. Then I'm going to pass the video a little bit faster. Now I'm going to load the data. It's going to be this one, and it's going to be the groundwater data set. Open, and we have to change this one. It's a different one. Going to change here. It's going to be 32,634. This one here. Okay. Add and close. Is this data set? Then I'm going to add a satellite imagery. This one. And now I'm going to run that script again. It's going to be this one here. Number 13 is this layer, and the parameter is going to be groundwater. This one is going to be groundwater elevation in meters. This one is going to be frequency. Title of the graph is going to be histogram plus box plot, raw data, and here I'm going to add the range. We can see the range over here. Going to minimize this one, put this one over here and this one over here. And the minimum value is going to be 90, 9A1, 90, 9A1, and for the maximum value it's going to be 96.566, 96.566, and we are going to create 8 bins in this case because we have just 57 samples and we cannot add more bins. That's enough. 96.566 less 90.9A1 equal divided by 8. Going to copy all this one, select all, copy. That is for 8 bins, okay? Paste, and I'm going to write these ones, but I'm going to pass it a bit faster. Save, and I'm going to run this one. But now, as you can see, we have to do a lot of modifications here because we have the labels is changing all the graph. Then what I'm going to do first is go here, edit, and I'm going to put this one around. If you check your data at the attribute table, I'm going to minimize this one. At the attribute table, we have that the values are around 96 and 90. Then I'm going to try 93. Then we have to make a better approximation. 93, for example, and 93. 93, and we saw that the range from the minimum value to the maximum, it was around 5 meters, okay? Then that's the reason because I put this for the same value. Then I'm going to save, but even the frequency I can change here. I'm going to try, for example, 10 and also 10 here, because we have in total 57 samples, right? And here was 35. That was too much. Then save, and I'm going to run this one again to see what happened. Execute. I close the windows. I make a mistake because I have to add all the values again, but I'm going to pass it very faster. Then I'm going to run the script and let's see what happened. Okay, now it's better. I'm going to make the screen bigger. But now what we can see is that the median and the mean, they are very close to each other, okay? And the value is around 93.5. That's what I'm going to move now the labels to 93.2 and 93.7, something like that, to put the median here and the mean over here. 93.3 and 93.7, for example. Let's see. Then go here. 93.7, and this one is going to be 93.3, and for the high around 10 is good, right? Okay, then go here, let's go to save this one, save, and let's go to run the script again. Okay, even I can put this one a little bit more close. Let me change this one. And that's how it works. Then, as you can see in this graph, the distribution is pretty normal. This distance from here to here is pretty normal to the distance from here to here. And we have also the box more or less at the middle of the graph, and the median and the mean, they are almost at the same position. It is also indicative of a normally distribution of the data. Then if we compare with the other graph, but I'm going to close this one, I'm going to close this one, this one, and this one. And as you can see, there is big difference, right? This one it's very to this side of the graph, and all the distribution also goes to this side, but here it's pretty central. Also in this graph, we can see that we don't have any outliers, and that is important. Okay, that's it for this lesson. Thank you very much for watching, and see you on the next video.